A monster is hiding in the Milky Way. It's a cloud so vast it stretches for 200 light years, and it carries the weight of 160,000 suns. For years, it went completely unnoticed, lurking in one of the galaxy's darkest, dustiest corridors. But astronomers have finally found it, and deep within its cold, dark heart, they detected a strange, unnatural signal, a focused beam of microwave light, shining like a laser in the cosmic fog. This discovery is happening now because of the unique capabilities of the Green Bank Telescope in West Virginia. Its immense 100-meter dish allowed an international team of scientists to peer through the thick dust lanes of our galaxy's central bar, a region that's incredibly difficult to observe. They weren't just looking at the cloud, they were listening to the specific radio signatures of molecules deep inside it. The press release detailing these findings gives us the first clear picture of this previously hidden region of space, a place we now know is turbulent and buzzing with activity.
So, what exactly is this colossal hidden structure? Where did that mysterious microwave beam come from? And what does this monster cloud teach us about the birth of the most powerful stars in the universe? This giant is what astronomers call a molecular cloud, a colossal accumulation of interstellar gas and dust. This one, officially named M4.7-0.8, is located about 23,000 light-years from us, right in the middle of a stream of material flowing toward the supermassive black hole at the center of the galaxy. It is a place of extreme cold, with temperatures dipping to just 20 degrees above absolute zero, making it one of the coldest known environments in space. This cloud is a true giant, a reservoir of raw material for future stars.
Astronomers found it by using the Green Bank Telescope to hunt for the faint radio whispers of specific molecules, like ammonia. These molecules only emit signals in extremely dense, cold gas, allowing the team to map out this massive structure that was otherwise invisible. The telescope essentially acted like a giant ear, picking up the chemical fingerprints of the gas and revealing the cloud's immense size and density for the first time. This discovery confirms that there are still huge, undiscovered structures hidden within our own galaxy. The most startling discovery within the cloud was the detection of a maser, a naturally occurring source of intense microwave radiation. It is the cosmic equivalent of a laser, but it emits microwaves instead of visible light. These masers are created when gas in a very specific physical state gets energized, causing it to release a powerful, focused beam of radiation. Finding one is a smoking gun, a clear signpost pointing to a very specific and dramatic event happening deep inside the cloud.
In short, astronomers have uncovered a gigantic, previously unknown stellar nursery right on the doorstep of our galaxy's chaotic center, and a mysterious natural laser is pointing out from its depths. This gives us a ringside seat to the very first stages of massive star formation in an environment we've never been able to study before. To get a sense of this discovery, we need to understand the tools involved. The key instrument was the Green Bank Telescope, or GBT. With a collecting area of over 2 acres, it is the world's most sensitive single-dish radio telescope, capable of detecting incredibly faint radio signals from the cosmos. The research team, led by Natalie Butterfield of the National Radio Astronomy Observatory, used the GBT to conduct a survey of a region they suspected might be a highway for gas flowing to the galactic center. Their data, published in the Astrophysical Journal, revealed not just the cloud, but its intricate internal structure.
Inside, they mapped out 2 key features: a bright, dense core they named the nexus, and a long, thread-like structure called the filament. These are the areas where the cloud's gas is being compressed, likely marking the very first steps toward creating new stars. One specific clump of gas, labeled Node E, appears to be a dense core on the verge of collapsing under its own gravity to ignite into a star.
The ammonia maser they found acts like a flashing beacon, pinpointing a region where this process is already intensely active. However, there are limitations. While the GBT can reveal the cloud's structure and motion, it's hard to see the fine details of individual forming stars through so much gas and dust, and precisely measuring distances in this part of the galaxy is notoriously difficult.
What this discovery changes is our map of star formation. For decades, scientists have debated how massive stars, those more than 8 times the mass of our Sun, are born. Unlike smaller stars, which form in relatively orderly disks of gas and dust, massive star formation is thought to be a much more chaotic and violent process. This new cloud, M4.7-0.8, is a perfect laboratory for testing these theories. It exists in a unique location, a transition zone where material from the calm galactic disk is funneled into the extreme, high-energy environment of the galactic center. By studying the turbulence and density of the gas here, scientists can refine their models of how stars manage to form and grow in such hostile conditions. The discovery of this monster cloud proves that massive stellar nurseries can exist in places we hadn't thought to look, fundamentally expanding the known territories where the galaxy's giants are born.
So, what happens next? In the immediate future, this cloud becomes a prime target for other powerful telescopes. The Atacama Large Millimeter Submillimeter Array, or ALMA, in Chile, could zoom in on the nexus and filament regions, revealing the smaller, denser cores that will eventually become individual stars in planetary systems. Its higher resolution could pierce through the dust and gas to see the very earliest stages of stellar birth in unprecedented detail, turning the GBT's wide map into a detailed atlas. Looking ahead to upcoming missions, telescopes like the James Webb Space Telescope could use its infrared eyes to study the chemistry of the cloud. Webb could analyze the composition of the dust and ice within the cloud, telling us what raw ingredients are available for the next generation of stars and planets forming there. This would give us a chemical blueprint of a stellar nursery in a unique, near-center galactic environment, and we could compare it to nurseries in our own calmer neighborhood, like the Orion Nebula.
Further into the future, this research paves the way for a deeper understanding of galactic evolution itself. The cloud acts as a crucial link, showing how a galaxy feeds material from its vast disk into its central engine. By studying this and other similar river clouds, future generations of astronomers could build a complete model of this galactic plumbing. This will help us understand not just star formation, but how the supermassive black hole at the galaxy's heart gets its fuel, and how the very structure of the Milky Way is built and maintained over billions of years. In the end, the monster hiding in the Milky Way was not a monster at all. It is a cradle. The strange, laser-like signal was not a weapon, but a natural beacon announcing the birth of new, massive stars. This colossal cloud, once invisible, has now given us a vital new landmark on the map of our galaxy. It highlights a critical step in the cosmic assembly line, where the raw, cold gas of the interstellar medium is forged into the brilliant, life-giving engines we call stars. From here, our exploration of the galaxy's star-forming heartlands is only just beginning.